So this is the fourth category, right? So first one is one disturbing mass and one balancing mass, both are in same plane. Second category, one disturbing mass, two balancing mass but in different planes. Third one, several unbalances but one balancing mass in same plane. Here we have the fourth category, balancing of several masses rotating in different planes, right? Several masses and different planes, right? So now we'll see how to do that. So as you remember, when we were discussing about second category, that is two balancing mass and different planes, we were discussing about the balance of couple also, right? Not only the force but the couple also. All right. So when several masses revolve in different planes, right? Several masses revolve in different planes, they may be transferred to a reference plane, briefly written as RP, right? That would be the reference plane, RP, reference plane, which may be defined as the plane passing through a point on the axis of rotation and perpendicular to it, right? So when there are a number of masses rotating, we can choose one plane as a reference plane, right? Which will exactly pass through as like the other planes through the center of axis, right? So here in this case, this RP is a reference plane, so which will pass perpendicular to the rotation axis, right? We will have number of unbalances 1, 2, 3, and 4. All right. Effect of transferring a revolving mass in one plane to a reference plane is to cause a force of magnitude equal to the centrifugal force of the revolving mass to act in the reference plane together with the couple, right? So here in this case, we will choose one plane as the reference plane and where we will place the balancing mass, right? So this balancing mass will satisfy both the couple as well as the force together with a couple of magnitude equal to the product of the force and the distance between the plane of the rotation of the and the reference plane, right? So now we will see how is it. So here this is the a kind of picture you can see. So here we have number of masses, right, rotating at different distances, r3, r2, rm, rl, r4, right? Like different distance, different mass, and also there are certain angles. So these angles are, you see, theta 1, theta 2, theta 3, and phi is also there. So this phi and this theta are different planes, right? So this theta 1, theta 2, theta 3, they can be of one plane, right? But this phi is of different plane. So that's why it's mentioned as different planes, all right? And here you see, based on the reference plane, we will start specifying the lengths, okay? Specifying the lengths. So on the reference plane to this number 1, that is L1, reference plane to 2, that is L2, reference plane to 3, that is L3, reference plane to 4, that is L4, so reference plane to M, that is LM, right? So these are the lengths, okay? These are the lengths between the planes, right? Now we'll see how to solve it. In order to have a complete balance of several revolving masses, right? Several revolving masses in different planes, the following two conditions must be satisfied, right? These two conditions must be satisfied. The forces in the reference plane must balance, that is the resultant force must be zero. So as usual, the forces must be balanced and zero. Then second thing, couples about the reference plane must balance, that is the resultant couple must be zero. So as like in the second category, that is one disturbing mass and two balanced mass. So the couple must be zero and the resultant force must be zero, right? So these two conditions must be fulfilled, all right? Let us now consider four masses M1, M2, M3, and M4, right? M1, M2, M3, and M4, these are four masses. Revolving planes 1, 2, 3, and 4 respectively, right? Planes 1, 2, 3, and 4 respectively, right? 1, 2, 3, and 4 respectively. The relative angular positions of these masses are shown in the end view, right? So here is the diagram for this first statement. Masses m1, m2, m3 and m4 are rotating in planes 1, 2, 3 and 4. Relative angular positions of these masses are shown in end view, right? So angular positions theta and phi, these all are shown in the end view. Now we will see how to solve this. All right. So to solve this, we need to put a table, right? A table. So here we have plane, right? So we have number of planes here, right? Number of planes we have 1, L, 2, 3, M4, right? 1, L, 2, 3, M4. These are the planes. And we need to specify 1 as the reference plane. You can specify any one of these plane, but what I do, I will specify L as the reference plane. All right. Then I need to put the masses, right? So mass in one plane 1, that is m1, plane 2, m2, that is given in the data. So m1, ml, m2, m3, m4 and mm, right? And then the radius, right? The radius from which the axis to this rotation, right? That is r1, rl, r2, r3, rm, r4, right? Now we will multiply this m and r. So that is a kind of finding the force, right? So finding the force you have done in the last numerical, right? So maybe we can leave omega squared and we can go with the m and r only, right? So here also I will go with m and r because that's easy to calculate, right? So you need to multiply this with this. There is m1 r1, ml rl, m2 r2, like this. You need to multiply. Then I have the distance from the plane L, that is the reference plane. Okay, so whatever the plane you are selecting as the reference plane, you need to specify the distances from that plane L, right? So that is, if I am taking this way as positive, this will be negative, right? So here minus L1, L plane, so this plane to this plane there is no distance, that is 0. Then L2, L3, L4 and LM, right? L2, L3, LM and L4, right? So these are the distances from the planes, right? Now I will find the couple. You know couple is m into r into L, right? Force into distance. That's mr squared, mr omega squared into L. So you will multiply this column with this column and obtain the answer for here. So here now it is m1 r1 L1 minus m1 r1 L1. Here there's a minus. So if you multiply 0 with this one, you will get 0. Then you can multiply m2 r2 L2, m3 r3 L3, mm rm Lm. Similarly, you will complete this table, right? So now you can find the reference plane. We will see how to do that. Not reference plane, the resulting mass, right? Now we'll see how to do that, right? So whenever you find such a case, right? Such a case in the sense several masses rotating in different planes, you need to go for this table. That will make your solution easy, right? Solving will be easy. So once you are done with this table, what you have to do is, we'll see a couple may be represented by a vector drawn perpendicular to the plane of the couple, right? So now we will see how to put them in the diagram, right? How to put them in the diagram. Couple may be represented by a vector drawn perpendicular to the plane of the couple, right? So here we have the couple vector, right? So C1, C2, C3 and C4, right? Take one of the planes, say L as a reference plane, right? Say L as a reference plane. The distances of all the other planes to the left of the reference plane may be regarded as negative and those to the right as positive, right? So this you can choose by your own. Either you can put this as negative or this as positive, or you put this as negative and that as positive, and tabulate the data as shown in the table. The planes are tabulated in the same order in which they occur, right? Reading from left to right. So it should be in an order, right? Don't jump here and there. That should be in the order 1, L, 2, 3, M4, right? 1, L, 2, 3, M4, like this, right? So a couple may be represented by a vector drawn perpendicular to the plane of the couple. The couple C1 introduced by transferring M1 to the reference plane. introduced by transferring m1 to the reference plane through O is proportional to m1 r1 l1, right? And act in the plane through OM1, right? Plane through OM1 and perpendicular to the paper, right? So now these are going to be perpendicular to the paper. So this is just a kind of drawing, but this is actually inside or outside of the paper, right? Vector representing this couple is drawn in the plane of the paper and perpendicular to OM1 as shown in OC1. Couple vectors, as discussed above, are turned counterclockwise through a right angle for convenience of drawing as shown in this figure, right? So actually what has happened here is these couple vectors are actually directed inwards to this paper, right? But we can't draw it inward, right? So what we have done, we then turn it by 90-degree angle, right? Are turned counterclockwise through a right angle so that we can put it in the diagram. For convenience of drawing as shown in this figure, we see that their relative positions remains unaffected. So if you are like turning the entire diagram by right angle, then nothing will change, right? Now the vectors OC2, OC3 and OC4, OC2, OC3 and OC4 are parallel and in the same directions as OM2, OM3 and OM4, right? So OM2, OM3 and OM4, right? While the vector OC1 is parallel to OM1. So OC1 is parallel to OM1, right? So it is mentioning about only the plane, right? OC1 is parallel to OM1, but in opposite direction, right? Hence, the couple vectors are drawn radially outwards for the masses on one side of the reference plane and radially inward for the masses on the other side of the reference plane, right? Couple vectors are drawn radially outwards, which means from this paper coming out towards you, that is radially outwards for the masses on one side of the reference plane, right? That is, say for example, if you take this as a reference plane, as for the one side of the reference plane, these all will be looking like coming out of the paper and radially inward for the masses on the other side of the reference plane. So for the reference plane is this, and for this side they will be going inside to the reference plane. All right. So now this is about force polygon and couple polygon. So this one we need to draw like one by one, right? One by one. So we will go with force polygon, then couple polygon, right? Then turning the couple vectors and finally arriving at the final answer. All right. Now draw the couple polygon. So